Good morning. So last time I stopped at soil acidity, so I'll just continue here. So what makes a soil acidic, or how do we measure acidity, is with the pH scale, and also what it means is we measure the hydrogen concentration within the soil. Okay, so the more hydrogen there's present in the soil, the more acidic it becomes, and the less hydrogen atoms we have, the more basic it becomes. You can also think of it as when there is hydrogen atoms present, or the more there are, it's more acidic, and also if there's more hydroxyl ions, OH, it becomes more basic. Okay, here are just a few examples of some things, household items that are either basic or acidic. And if you all remember, the neutral area is usually when the pH is at 7. And your best example of this is pure water. If it's pure, it should be at pH 7. Okay, so we get two types of acidity in the soil: reserve acidity and active acidity. Your active acidity is basically all those hydrogen ions and other types of cations in the soil that is freely available. It's loosely available inside the soil. It can be absorbed by plants, and if it maybe rains, it can be washed away. So it's in freely between soil particles. Your reserve acidity are those cations that are adsorbed by clay particles and humus particles, so your soil particles. They are close to the surface and they can't easily be adsorbed by plants. They are highly attracted, as we mentioned in the previous video, to these soil particles, and it's hard for them, so attracted like a magnet, positive particles to the negative particles. So they are kind of attached, physically attached to these soil particles. Okay, so specifically also your hydrogen atoms that are adsorbed, that causes the acidity or influences the acidity. Okay, so usually your reserve acidity is usually higher than the active acidity. So there's more hydrogen atoms usually adsorbed to soil particles than what there are freely available in the soil. Okay, so what causes the soil to become acidic? Things like organic acids, like your humus or your feces from animals, manure, that can add more hydrogen atoms to the soil and causes it to become more acidic. Things like higher rainfall can also cause it. In this case, what happens as soon as the rain comes in, it washes away most other minerals, free minerals in the soil. As soon as it washes that away, more water is inside the soil and chemical reactions happen, and then more hydrogen atoms are available in the soil, making it more acidic. Then there is carbon dioxide in the soil, if you remember. So it reacts with water and releases hydrogen ions. So as soon as that happens, more hydrogen ions are in the soil and becomes more acidic. Then lastly, fertilizers. If more acidic fertilizers are put inside the soil, it will increase the acidity. Things like ammonium sulfide is a good example of that type of fertilizer. The ammonium reacts or is free into the soil. It dissociates and gives more hydrogen into the soil. And the calcium or magnesium cations, if there is in the soil, react with the sodium, the sulfates. And then that washes away. So yeah, by the way, leaving behind more hydrogen atoms. So what are the effects of acidity, the negative effects? Why is it so bad for the soil? First of all, it changes the soil elements inside the soils. A good example would be like phosphorus and iron. They react with one another in acid soils, and this causes them to be unavailable for plants. And plants do need phosphorus and iron in minuscule amounts. So if those two react, and they only react in acid soils, they can't be absorbed by the plants. Then also it causes poor yields, and there's things like in acidic soil, aluminium becomes toxic to plants. So as soon as they absorb it, their roots start to shorten and they become stubby, and later on they can die. So it affects how much crop survive. Okay, then also it causes reduced productivity in roots. So if in acid soils, plants struggle to absorb certain minerals as well, so the roots don't do their work. Then also it causes reduced bacterial activity. So in certain acidic soils, things like nematodes, sorry, that's the next, pests and parasites increase, okay. But it's reduced bacterial activity, and that causes certain bacteria, like those nitrogen-fixing bacteria that are on the roots of the plants, and which the plants need because they give nitrogen to the plant. So that bacteria can die off, and then the plant will be negatively affected because it can't get the nitrogen it needs. Again, and also pests and parasites can increase certain worms and things that causes damage to the plants. They love certain acidic soils. So they can increase and do damage to plants, and also weak soil structure. So it allows for a free drainage. So if the soil structure is weak, water can't be retained, the plants can't get the water just runs off or percolates through the soil and isn't available for plants. So how can we prevent and treat this acid soil when we have it? So basically the best thing is to use basic fertilizers like your things that have your hydroxyl ions. So more basic fertilizers makes the acidic soil more basic. If you add more basic fertilizers, the pH will change, and hopefully what you want is actually a pH 7. It's always the best type of soil. Then avoid over-irrigation. As I mentioned, if there is too much water, most of the cations leaches out, and also more hydrogen ions stay behind, making it more acidic. Then cultivate acid-tolerant plants. If you know you have acid soils or the soil has become acidic, you can try and plant certain plants that actually love acidic soil. Then also adding lime. Now lime is calcium carbonate. So what this does is within this soil there are clay pieces with lots of hydrogen atoms attached to it or adsorbed by it. Okay, and as soon as you add the lime, what happens is the hydrogen is being exchanged for calcium. So now the calcium is attached to the clay, and you get carbonic acid. And when this dissociates, you get water and carbon dioxide. And you see H2O and CO2. So water and carbon dioxide is made from carbonic acid, or when it dissociates. Okay, so that's good. More water into the soil, more carbon dioxide. Okay, so looking at soil alkalinity or salinity, this is more to the basic side. What is alkaline soil? Okay, so again, what happens is there's a lot of sodium ions in the soil, sodium also called salt. And when these sodium ions react with water, what happens is that sodium carbonate is formed and CO2 is released into the air. But as soon as it's a hot day or something, the water evaporates, and as the water comes up, these sodium particles or the salts stay behind and are left on the surface of the soil, and then you see all this, they call it salt precipitates. It's on the surface of the soil, the salt stays behind. And it's also known as brackish soil. Okay, so your characteristics of a alkaline soil is the pH is always higher than 8.5. Remember, the more basic we are, the pH is, the higher it goes to 14. So it can be anywhere between 8.5 and 14. Then there is, like I mentioned, a high sodium amount, lots of salts. Then it causes poor structure. It's also called deflocculation. Deflocculation is a very fancy word just to say that the structure of the soil is being broken down. I don't know if you can see in this picture, but there's a few cracks forming in between the soil, apart from the fact that all the salt's on the surface. So the structure of the soil is being broken down. Oh, sorry. Again, also there are low amounts of organic matter. So the soil is not very fertile. And also there will be low amounts of water because of all the cracks and so on. When it rains and the water does go in, The water just percolates down due to gravity, to the lower levels of the soil or the lower horizons. So no plants or anything can actually grow here. There's not enough water for them to survive. So there are two types of brackish soils. You get white brack and black brack, also called saline soil and sodic soils. So how do we distinguish them? The white brack, the pH is lower than 8.5, so it would be anywhere between 7.1 and 8.5. And also the types of salts that are found within the white brack is your chlorides and your sulfates. Take note of that. Then your black brack, the pH is higher than 8.5, as we mentioned in this case in general, yeah, from 8.5 to 14. And also there are more clay particles inside the soil of the black brack. That's why usually it looks black, because there are more organic material and clayish material inside this type of soil. Then your sodium carbonate, is the main type of salt inside the black brack, more sodium. Then also the soil looks more deflocculated, the structure has been broken down a lot. The next photo is a good example of this. You can see all the cracks on this type of soil, deflocculation happening. Okay, so what causes your basic or alkaline soils? So alkaline fertilizers, it will increase the amount of hydroxyl ions in the soil and lessen the amount of hydrogen ions. Then the nearness of the ocean is also a factor. What happens here is if the soil is close to the ocean and ocean winds blow, then it blows some of the salts from the ocean onto the soil. So then the soil becomes more salty. Also, if the water which is used to irrigate the plants on this type of soil has a lot of salts, it can increase the amount of salt in the soil and make it more alkaline. Then also too much irrigation can also make it more salty. If you add lots of water to this structured soil with all the cracks and so on, yes, it will increase the amount of water for the plant, but what happens is it increases the water table. So the amount of water in the lower layers increases, and as the water rises, it brings the salt with it to the surface of the soil. And then as soon as the water evaporates, it leaves the salt behind. So then again, you get something like the previous picture with the salts on the surface of the soil. And then the plants can die. So another example would be for dried pans and lakes. In the Kalahari, there are lots of these examples. You get these flat areas which used to have water bodies on the surface, like lakes, there's water. But then in the hot summer months, when the temperature is very high, all of the water evaporates, and again, all the salt precipitates on the surface of the soil, and you get these salt pans. Then what is the negative effects of salty soil, specifically for crop production? And this is important for farmers to know. So first of all, the deflocculation, or this deconstruction of the structure of the soil, it changes the soil structure as mentioned, and also the water content. So yes, the water is not easily available for plants because the water just goes through to the lower layers. Then the high salt concentration, that's just a short way of showing concentration, makes water absorption for the plants also impossible. Okay, because even if the water is available close to the roots of the plants when you irrigate, because there's so much salt in the soil, the water would rather try and dissolve the salts in the soil. So then it also leaches through the soil and won't be available for the plants. So when you have alkaline soil, or even, to start with, before you have alkaline soil, how can you prevent or control this type of soil? How can you keep it neutral, good, healthy, fertile soil? So first of all, always give fresh water. Don't increase the amount of salts. Try and avoid that. Then give good organic fertilizers, manures, and also mulching of the soil to keep it to ensure that there's enough organic matter in the soil as well, and also ensure there's good drainage, and so that the salts can be taken down and the amount of salts in the soil decreased or kept low. Okay, so if it happens that the soil is alkaline, there's lots of salt in the soil, what can the farmer do to reclaim the soil? or make it, trying to make it neutral again. Okay, so what happens is the clay, there's lots of sodium ions attached to the clay again. So in this case, we have alkaline soil, pH probably above 8.5. What you can do, the farmer can do, is add gypsum. Now, gypsum is calcium sulfate. Just important thing to remember, gypsum has calcium in it. And as soon as calcium is added to the soil, what happens is it is exchanged for the sodium. So the calcium gets absorbed by the clay particle. This dot is a clay particle. The calcium takes its place. The sodium is now free in the soil. And as soon as there is irrigation done or heavy rains come, then all these sodium ions, or cations, will be washed away into the deeper parts of the soil or out into the river systems and so on. Okay, so the soil in this case has been reclaimed because calcium, if you remember in the previous slides, if calcium is added, I just need to keep my notes, calcium makes it neutral. Calcium and magnesium is the two cations that makes the soil neutral again. So in this case, the soil will be reclaimed. Okay, I'm going to stop here for today.